Okay. Thanks, Scott. Yeah. Actually, that way. Oh, you don't want it. Yeah, like, all good. Yeah. Oh, so annoying.
Maybe.
Oh, that's why I was turning on. Go right here.
That's why
Thank you. Congratulations. I think it's out. Yeah, they're running. I know. Yeah. The red one. I don't know if it's out though. Just fun. Yeah, the red one. Yeah. Having a 20 silence. Oh, how do we know what? That also. Oh, yeah, the double. That was good. That makes sense. That was really hard on me. I don't know. Yeah, literally. I don't know. Oh, and then like why is it special things? Like that's an idea. Oh. 6 ready. It's like cool. Yeah, it was like the sun's out. No, he didn't say anything for it. I'll say that.
At 21.
Oh, look at that. What's your number? Oh, what you say? You figure out. Yeah. That's what I'm saying. Like,
All right, it's 5:30. Let's go and get started. All right, good evening, everyone. Welcome to our second class session for 410. How's everyone doing today?
Good, how are you?
Good, good.
How are you?
Good. I'm doing good. Thanks for asking. Little less jet lag today. Okay, so today is our first Ansys activity, and so it is the same activity I've run I guess 6 years in a row now, and so it's the plate with a hole. So we've this is like everyone's kind of first Ansys activity, and so if you go to any online tutorial, it's kind of something too. So you're getting the intro to Ansys experience. Okay. So for those of you joining on Zoom, I apologize. I usually send out the instructions on installing Ansys. Not a couple hours before the lecture. So hopefully you're able to install Ansys. But if not, you can at least follow along and at least kind of see kind of what I'm doing. And then kind of try it out on your own once you either have Ansys installed or maybe you can come into the lab. The activity itself doesn't take too long. It's going to take the entire time today just because it's everyone's first time doing it. But once you kind of get used to it, there's not that much clicking. It's going to be more of me explaining things to you than actually clicking. Okay. All right, so we're going to go through the whole thing today. So we're going to go through opening up Ansys, how to create a geometry in Ansys, how to specify material properties, meshing, boundary conditions, viewing the results, and so everything on this very simple. Okay. Okay, so I was just informed today that that all the software should be updated for Ansys on all of these computers. But that said, you guys are going to be the first ones testing it, and so there might be some technical issues today, but we'll work through them. At the very least, I hope it works here as well. Oh yeah, for those of you on Zoom, the webcam's not working, so it's just my disembodied voice. But you can ask anyone in the class today. It's actually me. Here I'm not. Okay, so waitlist people, remember tomorrow what I'm going to do is I'm going to see who's on the waitlist. I think last time I checked there were 16 people on the waitlist, and so that's how many I plan to add in. So if you're top 16 on the waitlist, then you'll be in the class by. Okay. Okay. Any questions I can answer before we get started for today? Question? Yeah.
Does it matter for you?
So it will if you're planning on taking this home. And so if you're going to be working all in 2021, it's totally fine. But the student version that we download online is actually 2023. And so you can upscale. So you can take 2021 and go to 2023. That's fine. But you can't take a 2023 file and go back to 2021. And so just kind of be aware of that. But everything. So I made this activity. I guess almost 6 years ago, back in like the 2018 version of the software, and it's still the same, and all the activities are the same. It's just that be aware if you're going to be moving between. Okay. Okay. All right. So let's go and get started. Okay, and so the subject for our first activity here is this plate, right? And so it's a two-dimensional plate, and what we're going to do is on one side of the plate we're going to fix it to the wall. And so that's what kind of this indicates here is that this plate is either, imagine that it's bolted to the wall, it's welded to the wall. Either way, this side of the plate is not moving at all. Whereas on the other side of the plate, we're going to be pulling it with a tensile force P. Okay? And then what's going to happen is that the plate is going to stretch, it's going to deform, and then we're going to be able to see, how the deformation in the plate results from this force. As well as the stress distribution. And what you'll see is that the hole here actually makes a difference. All right, so let's open up Ansys. And so to open up Ansys, you're going to go to your start menu. You're going to go to Ansys here. And so it looks like the two versions that are installed here are 2020 and 2021. So I'm going to go ahead and use the latest version that's on here. And so if you click on the arrow of Ansys 2021 R1, you'll see that there are a ton of different programs here. And so, when you first kind of view this, it seems kind of intimidating in terms of what you should click. Okay. And so, the reason why there are lots of programs here is that Ansys itself is actually a collection of a lot of different softwares that are all kind of like duct taped together into like a working software. And so the way to actually run Ansys is to run a program called Workbench. Okay. And so Workbench is kind of like the manager software, which launches all the different software that we need. So let's go ahead and click on Workbench. And so on your computers, it'll be, if you're following along from home, it'll be Workbench 2023. I believe they're on R2 actually. But for everyone here in the lab, it should be Workbench 2021 R1. Fingers crossed, hope this works. Sign. Sign. No, I would not like to sell my soul to Ansys. No, thank you. All right, and so if you were able to successfully launch Workbench, you should be greeted with the following screen. So it should be mostly empty, but then what I want you guys to, or what you guys should be looking for is that on the left, you should see a box called Analysis Systems, and there should be kind of a lot of data. So is everyone able to open Ansys okay? And has this analysis toolbox? Anyone not able to open Ansys? Okay, good. All right, everyone say thank you, IT, for getting this done today. Because for a while it kind of seemed like maybe it wasn't going to happen, but they worked really hard to get this ready for you guys. So okay. All right, so now we are good to go. Okay. Everyone on Zoom open up okay, or at least the ones that are able to install. Okay, I'm going to assume that's yes. Okay. All right, and so analysis systems. And so if you look at this list right here, you can see here that there's a lot of different analysis systems. And what this basically shows you is all the different types of analysis you can run in F. The one that we're going to be using for the vast majority of this class is called static structural, which is a structural simulation that's static, and so there's no motion, and so it's still. Okay. But you can see there's a lot of other ones that we can do. So we can do fluid flow, so you can do CFD in Ansys, you can do thermal analysis, steady state thermal, you can do acoustics, you can do vibration, you can do dynamics, electrical even, you can do a lot of different stuff. Okay. But the one that we're going to be doing most of the time, and the one that we're going to be doing today, is static structural. Okay. And so go ahead and mouse over static structural, and you're going to click and drag it to the project schematic. And so when you click and drag it, you should see that there is a box that kind of shows up here. Okay. So what you want to do is you want to click and drag it to that box to create a standalone. Okay. And so after you click and drag static structural, you should have this box here. Okay. And what's nice about this box, and kind of what's nice about Ansys in general, is that it kind of shows you kind of all the steps that you need in order to complete that finite element. We have engineering data, geometry, model, setup, solution, and we're going to go through all of that. All right, before we start though, we need to make one very important change for today because we are running a 2D simulation. Okay. And so by default, Ansys assumes that you're going to be running a 3D simulation, which is not a bad assumption, just because the vast majority of the time you are going to be running. But for today, because it's our first Ansys activity, we are going to be running a 2D simulation. And so you're going to need to right click on. You can actually right click on anything there. And so for me, I right click on engineering data. You're going to click on properties here. And then once you're in the properties menu, you're going to click on geometry here. Okay. And then what that's going to do is that it's going to open up a lot of different options here for you. And you may have to click and drag this window here so you can see. And then the setting that we're going to change here is on line 19. Which is analysis type. And so you can see here that the default analysis type is 3D. But we want to change it to 2D. So we're going to click on this drop-down menu here and click on 2D for. Okay. So this is really important. And so you need to change it to 2D. Otherwise, there are some parts of the simulation that are going to show up a little bit weirdly. It's not the most debilitating thing. Like I said, once you start to learn Ansys, this activity will literally take you 5 minutes to do. But if you're following along with me, then it's good to switch it to 2D. Okay. Any questions on this so far? And yeah, feel free to help each other. You don't have to be totally quiet. It's a collaborative thing. Okay. All right. So make sure you switch it to 2D. That's going to be really important for it. Okay. And so the next thing that we're going to do is we're going to specify the material properties. So in this case, we're going to make sure that our material properties have the right values. Okay. And so remember, the material properties, what those are is we specify the type of material that our geometry is made out of. Okay. And so to check that, you're going to double click on engineering data here. Okay. And so by double clicking on engineering data, you're going to bring up another screen here, which shows you all the materials that you have available for this project. And so it's kind of a big change here, but the way I got here was I from the original screen here, I went to engineering data and I just double clicked. Okay. And so where you should kind of draw your attention to is kind of this section right here, kind of in the middle near the top. Okay. This is going to tell us which materials that we have available for this particular project. And right now we only have one material that's available called structural steel. So structural steel is the default structural material within Ansys, and it has the materials of steel, okay, or the properties of steel. If you look at the bottom here, you can see all the different properties of steel. Notably, you can see the density. The density is 7,850 kilograms per meter cubed. Okay. You can see the If you click on this plus arrow next to isotropic elasticity, this one right here, you can see things like the Young's modulus and the Poisson's ratio, as well as the bulk modulus and the shear modulus, which are computed. All right, so let's double check to make sure that these have the right values. Okay. And so if we go back to the activity specifications, if you scroll down on the first page, you can see here that we have values for the Young's modulus, which is 2.0 times 10 to the 5th megapascal, and the Poisson's ratio, which is 0.3. Okay. So let's double check to make sure that we have the right values for these properties. Let's jump back into Ansys. And first, let's check the Young's modulus. Okay. And so the Young's modulus would be 2 times 10 to the 5th megapascal. Okay. And so you can see here that the Young's modulus is 2 times 10 to the 11th pascals. And so let's switch the units here to make sure that we have the right values. Instead of pascals, let's change this to megapascal. And so by changing that to megapascal, we can see that the Young's modulus is 2 times 10 to the 5th. And so if we double check that with our project specification, we can see that that has the right value. So the Young's modulus is correct. And then very quickly, we can check the Poisson's ratio, which is 0.3, and it's supposed to be 0.3. Question in the chat? Okay. Okay, so the material properties should be correct. So you shouldn't have to change the material properties, but I wanted to at least show you where they were, because with our next activity in 2 weeks, activity 2, we're going to be modifying the material properties. But for today, we're not going to change it, but I just kind of wanted to show you where they were so that you can verify that they were. Okay, any questions on these? Okay. All right, so now that our material properties are correct, let's go about let's go ahead and construct our geometry. This activity is a little bit unique because normally I would give you a CAD file that you could use for the activity, but because this is so simple, we're just going to draw the geometry ourselves. Okay. Okay, and so we're going to use the built-in CAD software within Ansys. Okay. Well, we're going to use the one called design model. And so you're going to right click on geometry and then you're going to click on the button for new design model or geometry. And so you need to be careful here because Ansys actually comes with 2 CAD softwares. Well, and if you're running with 2023, it actually comes with 3. But you know, the one that we're going to use for this one is design model, which is the one that's a little bit simpler. Okay, so let's go ahead and click this. It's going to open up a different software. And so you should have a screen that looks like the following. Okay, so there should be kind of menus and stuff. So was everyone able to open up design modeler? Your screen looks like this. Okay, so let's go ahead and construct the geometry. And this is always really annoying to do on Zoom because the menu. All right, so the first thing I'm going to do is we're going to change the units here. And so you're going to go to the top of the screen. You're going to click on the button for units, right? And you can see that the default units here are in meters, right? Our part isn't that big. Our part is actually measured best in millimeters. And so we're going to change the units here to millimeters. Let's go ahead and click on millimeters there. And so the next thing we're going to do is we're going to change the view so that we're looking directly at the XY plane. Okay. So there's a couple ways that you can do this. The easiest way that I found is that you can go to the bottom right of the screen. And so if you look at the bottom right, there is a kind of a coordinate axis here. And what you're going to do is you're going to click on the Z axis, the blue arrow. And then what that's going to do is that it's going to default you to looking right down, right down the barrel for the Z. Now we're looking directly at the XY. Okay. All right. So now that we're locked on the XY plane here, so let's go ahead and start sketching. Okay. Hopefully, you should be familiar with the concept of sketching in CAD. We're going to click on the sketching button here. And that's going to open up the tools for us to making a sketch. Okay, and so if we look back at the activity figure here, you can see here that we're drawing a rectangular plate. And so let's start with the outside of the plate. Let's go ahead and draw a rectangle. I'm going to click on rectangle here. And then what that's going to do is that it should change your mouse cursor to a pencil. If you click once in the graphics field, you should see that it should start drawing the rectangle. And if you click again in the lower right-hand corner, that should finish drawing your rectangle. Go ahead and draw a rectangle. And it should be somewhat centered on the origin. Doesn't have to be exactly centered on the origin. It just kind of has to be close enough. So we're going to dimension this in a second. But for now, just go ahead and draw a. Everyone able to draw a rectangle in the in design modeler? Okay, so let's add some dimensions, and so let's go ahead and make sure that this rectangle is the appropriate size for our application. Okay, so let's go back to the project specifications. Oh, by the way, this is posted on Canvas, and so if you want to follow along, or even if you want to jump ahead, what I usually do is if you go to the assignments tab on Canvas. You click on the Ansys activity, there is a PDF here that I'm basically following from. Okay. And so if we look at the dimensions of our rectangle here, we can see that its length is 300 millimeters and its width is 200 millimeters. Okay, so 300 by 200 rectangle. So let's go ahead and add the dimensions in here to make sure that we have that right. Let's start with the length. And so the length, we're going to click on dimension. And so on the left-hand side of the screen here, you should see a button for dimensions. So let's go ahead and click on that. Make sure that you have the general dimension tool selected. So make sure you have this one selected here. And then what this is going to do is it's going to allow you to click on any of the edges of the rectangle and specify its dimension. Okay. All right, so let's go ahead and click on the bottom edge. That's going to let us specify the length. And then let's go ahead and click on the left side here. That's going to specify. All right. So now we've defined these two dimensions. And you're probably wondering, how do we actually specify those values? Okay? And so you're going to hate this, especially coming from SolidWorks. But the way that you specify the dimensions is actually not in the graphical window here. You actually specify it in the bottom left hand side here. Okay? And so if you look at your dimensions here, for me, I have a dimension called H1. And so you can see in the bottom left here, H1 has a value of 100. Right now, it's 101.31 millimeters. And so I'm going to use my keyboard. So I'm going to change this. So this is going to become 300 millimeters. Okay. Go ahead and enter 300 using your keyboard and hit enter. And then that's going to change the dimensions of that part of the rectangle. And then our other dimension here, V2. Right now, for me, it has a value of about 70. And so we're going to change this to 200, which is the appropriate height for the. Definitely feel free to zoom out on the screen just so you can see it all. And if you want to pan, if you want to move the sketch left and right, the way that you do that is you hold Control on your keyboard, and then you hold on the middle mouse button as well. Control and middle mouse button, click down. That's how you pan the screen. Right, and so now our rectangle is the appropriate size. It has a length of 300 and a width of 200. Any questions on this so far? Everyone good? Great. Okay, so the next thing that we're going to do is we're going to center this rectangle on the origin. It's going to make drawing the hole a little bit easier. And so you can see here, at least for me, my rectangle is pretty far off center. Okay. And so I want to center this rectangle on the origin just to make it easier to draw. And so to do that, we're going to use the other dimensioning tools. And so I'm going to start with horizontal. And so what the horizontal dimensioning tool is going to do is that it lets us specify a horizontal distance in our figure. Okay. And so the horizontal distance that I want to specify is the distance between this vertical edge and the y-axis right here. Okay. So I'm going to click on this vertical edge here, and it should highlight yellow. And then I'm going to click again on the y-axis, and that's going to let us define this new dimension here, which for me is called H3. All right, so that H3 should be about 1/2 of H1, just to make sure that it's centered. And so I'm going to set this equal to 150. And then I'm going to do the same thing with the vertical dimension. And so I'm going to specify a dimension between the x-axis and the bottom edge of the rectangle. So that'll give me a new dimension V4. And so this should be 100. Just to make sure our rectangle is nice and centered on. All right. And so if you do all of that correctly, your rectangle here should have a solid blue edges all around. And so if you remember from before, the rectangle had kind of a lighter blue color. But now that it's all solid blue, we know that each edge of this rectangle is fully dimensioned. So its position is fully fixed in space. Okay. All right. Any questions on this? Okay. All right. Good. We're going at a good pace. Okay, and so the next thing we're going to do here is we're going to draw the hole in the middle. Okay. If we go back to our figure here, you can see that we have a hole in the middle. It's the name of the activity. Point with the hole. And so we want to draw a circle in the middle of this rectangle. And so we're going to again use the draw tool. So again, you're going to click on this draw tool right here, and then you're going to click on circle. And so that's going to let you draw a circle in the sketch. Okay. All right. And so the hole that we're going to draw here is going to be located in the middle of the plate. We're going to click on the centroid of the rectangle here. If you click and drag the mouse, you can see that we can make the hole different size. We're going to dimension the hole, so you can kind of click on it arbitrarily. Okay. But you want to make sure that the hole is centered on the okay. All right, so we've drawn our circle here. And so of course our next step here is going to be to dimension it. So let's click on dimensions here. And then we're going to go on general dimensioning tool again. Let's click on this circle. And then we can see we have a new dimension V5. Okay, and so if we go back to the activity, we can see here that the dimension of the diameter of the hole should be 50 millimeters. Let's go ahead and specify this as 50. Okay. And so you should have a plate that's 300 by 200 with a hole that has diameter 50 in the middle of it. Okay. Right. Any questions on this, on any of the sketching?
Does the circle snap automatically to the origin?
If you put the mouse close enough to the origin, it should snap automatically. Okay. All right, so we're just about done here. And so the last thing we have to do is we actually have to turn this into a surface. And so you can almost think of this as like we're kind of extruding it. We're not really extruding it because we're doing a 2D simulation, but we have to kind of let Ansys know that, you know, we don't just have a sketch here, we have an actual solid. Okay, and so to do that, you're going to go to the top. Actually, let's do this first. So since we're done with sketching, so let's go ahead and exit the sketching menu. And so we're going to click on modeling down here. Okay. Go ahead and click on that. And so it should take you back to this screen here. Okay. And if you actually click on the plus arrow from XY, you should see that we'll have one sketch here, which is sketch 1. Okay. All right, so we need to take this sketch 1, which is right now it's just a collection of lines, and we need to turn it into a surface that we can use FEA simulations. Okay, so to do that, we're going to click on concept, and then we're going to go on surfaces from sketches. Okay. All right, so after you click on surfaces from sketches, it's going to create a new object right here called surface SK1. And the way we're going to specify the properties for this, we're going to be in the bottom left-hand corner. A little too many lines. Okay. And so there are two settings that we need to set here on surface and SK1. So we need to specify the base object, and we need to specify the thickness as well. Okay. Okay. So the base object here is going to be the sketch that we just created. And so what you're going to do is you're going to click on sketch 1. Okay. After you click on sketch 1, all the lines there should highlight yellow. Okay. And then after that, you're going to go to the bottom left-hand side of the screen, and you're going to click on apply. So after you click apply on the bottom left, you should see the base object should be one sketch, and that one sketch should be sketch 1. All right. And so that tells Ansys that, you know, this is the sketch that we want to turn into. We want to make sure that you select that sketch. The second thing that we're going to specify here is the thickness. And so the thickness of the geometry, it's going to be how thick this plate is going to be in the Z direction, right? So even though we're running a 2-dimensional simulation, you know, we have to add basically what's called an artificial thickness to the plate. Just so that we can solve all of the equations. And so this thickness is not actually going to show up in your model, but it's more of like a parameter that you have to specify for the. Okay. And so if you go back to the project specifications here, you should see that our thickness here is 5 millimeters. Let's go ahead and specify that here. So our thickness is going to be 5. So after you specify the thickness is 5 millimeters, we're going to go ahead and generate. So let's go ahead and click on this little lightning bolt here. Let's generate. And so after you click on generate, you should see that the surface should show up, right? And so Ansys is smart enough to see that if you have a closed sketch inside your closed line within your sketch, that's a hole. And so after you click on generate, you should see your plate show up as gray with the hole in the middle. All right, and so that's it. That's our geometry. Any questions on this? Was everyone able to get the plate with the hole? Okay, cool. So we are done here. Let's go ahead and exit out of Design Modeler, but you want to be careful here because you don't want to exit out of Workbench. You only want to exit out of Design Modeler. Okay. And so if you look at the bottom of your screen here, you have two windows open. So you have both Workbench and Design Modeler. So you only want to exit out of Design. Right, don't worry about saving it. So Ansys already saves it automatically. Okay. And so, Ansys doesn't throw anything away unless you close Workbench. Okay, so you want to make sure Workbench is always open, but you can close any of the other windows. All right. So before we jump into the next step, I want to kind of point something out to you. And so now that we have constructed our geometry, what you should notice here is that we have a green check mark next to geometry here. What that green check mark indicates is that it means that Ansys says your geometry is good. Okay? The green check marks, Ansys uses green check marks to tell you that that step is satisfied, it's all. And so, maybe, if you have photographic memory from like 20 minutes ago, probably you remember that green check mark actually used to be a question mark. But now that we've already constructed our geometry, that is now a green check mark. So our geometry. All right, so the next step in the process is going to be the modeling. And actually, we're going to do everything else in the same software. So the modeling, the setup, the solution, and the results are all going to be. Let's go ahead and double click on model. It should have this kind of green refresh symbol here. And what that's going to do is that it's going to open up another program called Ansys Mechanical, which is, honestly, probably where we're going to spend the majority of our time. All right, Mechanical takes a couple moments to start up. So, it may seem like your computer's doing nothing, but, it actually is trying to start up Mechanical. And if you actually look in the bottom left-hand side of the screen from Ansys Workbench, you should see that there's a little message there that says starting Mechanical. But even that, it takes a couple minutes to start up. So give it a little bit of time. Yeah, questions? Okay. Yeah. So while this is starting up, so everyone, when you start at Mechanical, you should see this screen right here. Yeah. If you have any questions, let me know, and I'll come around it. We're a little ahead of schedule, so.
Sometimes, yeah, the one of the host, and I think already know it. Sometimes we don't. Yeah.
Yeah, I'll give them programs.
My computer is little.
It's like one of them, right?
Actually, I think so this would be. Yeah.
Any other questions? Good. Everyone on Zoom doing okay? You guys doing all right? Okay, so was everyone able to open up Mechanical okay? Everyone sees the following screen on their computers? All right, okay, so right now the screen you're actually viewing is an advertisement, and so it's not actually your part here, and so to actually go and view the part or the part that's actually useful, what I like to do usually is I click on geometry. And so if you click on geometry, you should see your part. And the visual control is the same. So if you want, and you can hold control on your keyboard and hold the middle mouse button. Okay. All right, and so the main thing that's going to organize our work here is kind of on the left-hand side of the screen. We're basically going to go through all the steps here, and everything that doesn't have a green check mark, we're going to be busy. Okay, so first let's look at the mesh. And so if you recall from Tuesday, the meshing is a very important step for finite elements, right? And so in the meshing step, we're going to take our geometry here and then break it up into a lot of simpler shapes. Okay. All right, to kind of show you what I mean, let's go ahead and generate a mesh. Okay. So let's go ahead and right-click on mesh right here, and then let's just click generate. Okay. And so what this is going to do is that it's going to have Ansys create what's called the default mesh. Okay. We're using just the default settings to generate our mesh. So default size, default shape. And it should be pretty fast because this mesh is actually pretty not a very good mesh, but it'll serve us to get a point. Okay. So was everyone able to generate a mesh? It maybe doesn't look exactly like this, but it looks kind of something like this. All right. And so you can see, what's happened was that Ansys basically took our geometry and broke it up into a bunch of, in this case, squares, okay? Or at least four-sided polygons. I guess that's more. And so you can see here that it has four sides, four edges, and even all of the elements near the hole, they may look distorted, but if you actually look at those elements, they should have four sides. Okay. Some of you may have triangles, and so sometimes Ansys defaults to triangles, but either four-sided polygons or three-sided polygons, you should have a mesh that looks something like this. Okay, so let's refine the mesh. And so if you recall on Tuesday, what we said is that the accuracy and the reliability of your simulation depends kind of strongly on how big the elements are. Right? So these elements are actually pretty big. They're not that small. Let's go ahead and refine their size. Okay. And so if you look in the bottom left-hand side of the screen, you should see, after you click on mesh, you should see that there is a setting for the element size. And right now the default, we're using the default size, which is 0.303. Let me do something really quick just to kind of make things a little bit more convenient. And so if you go to kind of the top of your Ansys menu, you should see here that there is a setting for the units. So let's go ahead and change those units to millimeters, just like we have it. And you can see here there's a couple options for millimeters because there are different options for how you specify the mass or the force or things like that. Let's just use the third one down here. So millimeters, kilograms, newtons. Okay. And this is just a convenience thing. So if you prefer to work with meters, that's fine. But I like to use kind of whole. Okay. And so you can see here that our default meshing size now is about 30 millimeters. Okay. So let's go ahead and change this. Let's actually make it bigger first so you can see. And so what this is basically saying is that right now the size of each element or the length of each element edge is about 30 millimeters. Of course, there's some variance, but it tries with 30. So let's set the element size. Let's set it to 50, and then let's regenerate our mesh to kind of see what that looks like. So go ahead and change the element size to 50. Let's right-click on mesh. We'll go ahead and generate the mesh again. And you should see that the mesh updates a little bit, right? But it didn't really make that big of a difference because we're kind of already kind of not having a very good mesh. Okay. Okay. All right, so let's go the other direction now. And so instead of making the element size bigger, let's try making the element size small. Okay, so instead of 50, let me insert 10 here. Okay. And so we're going to try with an element size of 10. So let's right click on mesh. Let's go ahead and click on generate. And you can see here that now we have a mesh that's much nicer than before, right? All the elements are very neat and organized, with the exception of around the hole. We have a little bit of distortion around the hole, but overall this mesh is very good. And you can even go even further. So, you know, let's say that we change this down to 5. Our elements will be about half the size. And we have an even better mesh. And so our mesh here now looks even better than. Right. And so you can choose whichever element size you want. For this activity, it doesn't make too big a difference. As long as you're kind of in the ballpark of around 10 millimeters, then you should be good. All right. Any questions on the mesh? Everyone able to generate mesh? Okay. Yeah.
Smaller the mesh, the more accurate.
Exactly. Yes. Yeah. For this one, it's not going to matter too much because it's really simple. But for the more complicated cases, then you know, finding the correct mesh element size is something that's really cool. All right. Any other questions on the mesh? Okay. All right. So now that we're done with the mesh, the next step here is to apply the boundary conditions. Okay. All right. And so the boundary conditions, if you recall from Tuesday, those refer to the constraints and loads that we're going to place on this plate. And so we have one constraint here, and we have one load. Okay. And so the constraint that we have on the left-hand side is we say that this side of the plate is fixed. Whereas on this side of the plate, we're going to apply a load. In particular, it's going to be a tensile load. So we're going to be basically trying to pull the plate away from its fixture. Okay, so we have basically two boundary conditions that we need to apply. We need to apply a fixed boundary condition on the left-hand side, and we need to apply a tensile force, or in this case, a tensile pressure on the right. Okay, let's go back into mechanical. And the way that we're going to insert boundary conditions is we're going to insert it onto this object called static structural A5. All right, so we're going to right click on static structural A5. We're going to insert. Okay. And you can see here that we have a lot of different boundary conditions that we can apply. We're going to go over not all of these, but we're going to go over quite a few of them throughout the class. Okay. But for now, we're just going to focus on the fixed support. Okay. All right, and so if you mouse over fixed support, you can kind of read a little tooltip about it. And so you can see here that if we insert this fixed support, it prevents the selected geometry or mesh entity from moving or deforming. So that's perfect. So that's exactly what we need for the left-hand side. So let's go ahead and click on fixed support. And after you click on it, you should see that it'll create a new fixed support object here in your output. Okay. But the problem is, you know, that fixed support object has a question mark next to it, because right now Ansys doesn't know, it doesn't know where you want to apply this fixed support, right? So not only do you need to decide the type of boundary condition, you need to specify where you want to apply that boundary condition. Okay. All right, and so for our case, we want to specify it along this left edge right. All right, so let's go ahead and click on that left edge. And if you are good and not an old like me, you should be able to click on this edge by itself. But if you're having issues clicking on just that edge, because sometimes you might click on the whole thing, right? Then you can kind of force Ansys to select just an edge. And so if you go to this part of the screen right here, you can tell Ansys to snap your mouse at either certain kinds of entities. And so if you click on this one right here, which is the box with just the green line on top, this will tell Ansys that you want to snap to an edge. And it'll be a lot easier to click on that edge. And so even with jittery hands, you can. Okay. And so you want to make sure that you have just that left edge selected. Okay. And so when you selected just that left edge, you're going to click on apply. Now, and what that should change is that in the bottom left, you should see one edge for that fixed support. Any questions on that? Okay. Wow, this is going really smooth. Okay. All right, so now that we've applied our fixed support, our next step is to apply our load on the right-hand side. Okay. And the way that we're going to apply that is actually as a pressure. And so the units for P here are given in terms of pressure. So our loading P is going to be 1 times 10 to the third megapascal. Okay. Okay. Let's go ahead and apply that. And so just like we did for the fixed support, we're going to right click on static structural A5. We're going to go to insert. Okay. And then what we're going to insert here is a pressure boundary condition. And so if you read the tooltip for the pressure boundary condition, you can see here that it says to insert a pressure load that applies a constant pressure in a single direction on a flat or curved face. Okay, so let's go ahead and click on pressure here. And just like we did for the fixed support, we're going to click on edge. But instead of the left edge, we're going to click on the right edge of the other plate. Remember, we're applying this pressure on the right edge of these. And then we're going to click on apply in the bottom. All right, and so now that we've specified where we want to apply our pressure, the next step is to specify how much pressure or the magnitude of pressure that we're going to specify. Not only that, we want to specify the direction of the pressure. Okay, and so we're gonna do this all on the bottom left-hand side of the screen. And so the first thing we're going to change is this applied by setting here. And so instead of being applied by the surface effect, right above it. And so we're going to change this defined by. Okay, and so instead of defining the force direction as normal 2, we're going to change that direction to vector. And so what vector is going to allow us to do is that it's going to allow us to specify the x and y components of the pressure. Give us a little bit more. Sorry, not vector, components. Components is the one that we want. Okay, and so after you've changed the defined by components, you should see here that it gives you the option to specify the x component of the pressure and the y component of the pressure. Okay, and so we have no y component, and so our pressure is going to be completely in the x direction. So we can leave the y component at 0. But for the x component, we're going to specify this as 1 times 10 to the third, 1,000. Okay. So was everyone able to specify the pressure boundary condition on the right-hand side of the book? Sure. So for the pressure boundary condition, the way we want to do it, there's a couple things we need to change. And so after you've selected the right-hand side of the plate here, we're going to define our pressure in terms of components. So you're going to change this setting for defined by, you're going to change that to components, okay? And then once you kind of change that to component, it'll give you the option to change the x component of the load. And so we want to change that x component to 1,000 megapascal. All right, everyone able to get this, get these boundary conditions? I'll come around in a bit to kind of see, but. Quick question?
I don't have a question.
Oh, okay. I'll come by after this to check it out. Yeah. All right, because we're just about done. And so now that we have the mesh specified, we have the boundary condition specified. The last step here is just to solve it and look at the results. And so before we look at the results, let's go ahead and right click on solution A6. Okay. And we need to specify what type of results that we want to view within Ansys. Okay, so we'll go over these, a lot more later, but let's just go ahead and specify a few things. Okay. So first thing I want to specify here is the total deformation. And so we're going to right click on solution A6. We're going to go to insert deformation, and we're going to go to total here. Okay. Next thing we're going to insert is the stress distribution. You're going to right click on solution A6. You're going to go to insert. You're going to go to stress, and then you're going to click on equivalent von Mises stress. And then let's go ahead and add in the maximum principal stress as well. Again, you're going to right click on solution A6. You're going to go to insert stress and then maximum principal stress. Okay, so you should have three different results here. Okay. And so now that we are done here, let's go ahead and click solve. And so the solve is this kind of nice big lightning bolt in the top of the screen. It shouldn't take too long to solve this, even with our reply. And so if your simulation ran correctly, you should have a figure that looks something like this. And you can check the different results here. And so we have the total deformation, we have the equivalent stress, and the maximum principal stress. All right, so the way to kind of read these figures here is to go by the colors, right? And so remember we talked about on Tuesday that the red colors often indicate the maximum of that point. So for example, when you're viewing the total deformation field, the red colors tell you where the deformation is the greatest. Okay? And so in our case, the deformation is the greatest on the right-hand side of the plate. And the deformation is the lowest on the left-hand side. And so if you look at the color bar here, you can see that we have a value of 0 deformation where it is this kind of deep dark blue. And then our maximum deformation here is about 1.68 millimeters. And then we can look at the stress field as well. And so the stress field, you can see we have a maximum stress of about 3,322 megapascal. Okay, and that is occurring on kind of these top edges of the hole. And then we have a minimum stress of about 215 megapascal, which is occurring. Okay. Is everyone able to get simulation results, or are people kind of I'm gonna come around in a bit. Okay, so before I kind of walk around, for those of you who were able to get the simulation, there are other parts of the activity that you can start to work on right now. If you scroll down to the very bottom of the activity PDF, you should see here that there are additional problems for you to do. And so there's problem 1, which is interpreting the result that we just got. Problem 2, I want you to basically change some things around. Okay. So I want you to change the loading, change the size of the hole, change the mesh size, and I want you to see how that affects your results. And then for problem 3, I have some short answer problems. Okay, so for those of you who have finished, go ahead and start working. And so we basically did everything for problem 1 here. So there's a little bit I want you to write. But go ahead and start working on problem 2 and see how that does. And if you weren't able to get the simulation results, go ahead and raise your hand, and I'm gonna come around. Okay, so you're running an analysis in LS. Yes, but I think you can reuse some of the steps. This is a little bit advanced. So what we're basically doing is we're taking.
It's actually.
But we're basically saying that we're going to share the time. LS Dyna is a dynamic single store. Static. You might have to rematch it and then apply the boundary. Okay, send me, well, I'm gonna add it tomorrow, but I'm going to send it, you know, and I can give you back. You have to say, same from the word. I'm just gonna say like a file.
It'll include this.
Exactly. Yeah, we'll I'll talk about saving it. Yeah, there's gonna be a little bit of variance, but it looks like you got it. And so it's never gonna be exact. I think, but, all right.
Back to screen 3 times. And just keep it. You can still. I'm not allowed to. Actually, yeah. Picture this as a 2D. I kind of messed up the unit. I try, so I don't. Yes, I missed it. Okay, so the. So you can imagine, so they're buying 300, that's 300. So that's why it's taking forever. Right? Let's go ahead and make it close. Yeah. The units are correct. That's what happened. I should for a little bit. Yeah, I'm going to really cool man. It's the community, but it's a lot of it'll be a good thing. Yeah. Yeah. There were. Yeah. Yeah. They're trying to roll it out. So what we have for me, like what's the top? 3 stories. Graduated. So this one. Oh, next one. They're all older. I got it. So you change it.
Actually changing the whole like. So you're gonna close.
Things in the whole areas of manifest scale. So
Oh my God.
yeah, we're doing like,
But.
I mean, like turning in the assignment, we're doing like Word docs.
That's perfect.
And so
So most of the questions we answer, like I said.
Wait, that-
like it's just probably gonna do that.
Yeah. I always see. So you need to close it. Yeah. Yes, sure, as long as you don't. Once you close it, it kind of like. They go back to your. Gonna ask you to get load. Yeah, it should have your. Yeah, the workbench, you can always make it like style and afterwards. Yeah, it's been there. Yeah, that's kind of everything.
Oh, yeah.
Awesome. It's in good work, like.
You guys doing okay? Good.
I don't know, a little salad. You know, want to get. You can change it. You can change it. Oh, no, I didn't. How it was. Yeah. No, I don't.
Yeah.
Okay. And so like I keep back.
Okay, yeah, the whole is. Okay, looking at straight. I'm checking it out. Correct, brain or something, same, but the one I use. Okay, so you want to be careful. Strain. I mean, this is a linear material, so strain, stress and strain. You have to go quite. Stress. Yeah. Go ahead. So if you go to the activity, well, actually, you can, but this is. It's not just like 5 minutes.
And then where I would put the information that was on.
Exactly, yeah, so activity 2 for actually I'm not hard in. I'm just kidding. Yeah, you can make all the. Yeah, whatever in the magazine. Okay. Oh, you How about you? Oh, no. Okay. You're ready. Yeah. There is a. I have family. Yeah.
Damn thing.
All right, one last thing before you guys go today, which is saving these files. And so so saving an Ansys project is actually not as straightforward as you think. Because because there's multiple different programs that Ansys uses, there's actually also a lot of different files that need to be saved as well, because you need files for the CAD file, you need files for the mesh, you need files for the boundary condition information. They're actually all stored in separate files. The way to typically save it is through Workbench, right? And so if you save it through Workbench, and so let's say that I'm going to save as this test. Save it on the test. Okay, and so if you just save it normally, go to the desktop, you'll see that there is it creates a few different files. So it creates one file right here called the Workbench file. Okay, and so when you're first using Ansys, you would think like, oh, that file has everything that I need. And then I would save that file on Dropbox, I would take it on a flash drive, and then I take it home and I can work on it. What a lot of people don't realize is that in addition to this file, it also creates this folder right here. So this folder, this is the one that actually has all the files. So if you go in here, you can see that we have all these different files. It's actually quite fun. And so, to actually save a project, it's you can't just save this file right here, and you can't just save this folder. You need to actually zip it all up into a its own. And so to do that, we're going to go on to Ansys Workbench here. We're going to go to File, and then we're going to click on this button here called Archive. And so what that's going to do is that it's going to use basically a file zipper within Ansys to basically package everything up into one file. Let's click on Archive. And it's going to ask you where you want to solve it and save it, excuse me. And so we're going to click on, we'll call this test project. Okay. And so we're going to click on Save. And then after you click Save, another window is going to pop up and it's going to ask you, some optional items that you want to have solved, okay, or saved. Right, so you can just use the default here. The default is fine. So you're gonna go ahead and click Archive. It's gonna take a couple moments, and then after that, if you go back to your desktop here, you should see that it should produce a new file with like a little zip. Okay, and so this is the file that you want to save. Okay, and so if you're gonna move this project at home, if you're gonna continue this project, at home. If you want to save it to your Dropbox to work on another day, this is the file that you want to just. Okay. So don't move the default file. So don't move this folder and this file right here. You want to move the one with the zipper because that's the archive. Yeah. It should be okay because right now when you have its own version of files. And so these files here are just kind of copies of that, so you can delete it. But usually the same thing is, don't delete anything until you're done. Yeah, so that's important. 'Cause I know probably quite a few of you are still gonna be working on this. All right, and then the due date for the project, would be 1 week from today, so it'll be next Friday, September. All right, any final questions on this before we wrap it up for today? All right, so that's about it. And so thank you guys for coming today. Hope you guys enjoyed your first taste of Ansys. And so we'll pick this up again on Tuesday where we'll go over some background. All right, so hope everyone has a good weekend. I think there's a class after this, so I don't think you guys can stick around too long to take your you guys have a good weekend, and I'll see you guys next Tuesday. Yes, yeah. So yeah, tomorrow I'm gonna have class on the wait list. Yeah, it's hard. Yeah. Not officially in the class, but I do have some handouts on it. I can give you those handouts. If you're gonna run CFD, honestly, go on home. Viewing results. So you can actually run. So usually you So Dr. Myro actually knows a lot more. Yeah, I wouldn't know. He knows way more than that. Yeah. And actually next semester he's teaching a new CFD course. So. They don't let you sit on the course. Yeah. So Ansys is actually pretty good at formulas. T transfer actually is honestly probably the easiest equation to solve. Ansys. But yeah, you can definitely do thermal analysis. That a little bit, not. It's kind of like a little bit. So I have a handout for it. No, it's WB. Yeah. Theory, yeah. Simulation we use. They do Ansys for the mesh. I assume you can use OpenFOAM, use something else, right? Exactly. In theory, not really. Okay. Blender's okay. I think Ansys' measure. I mean, Ansys' measure is designed. Assume you get a better quality. Yeah, so actually, that's a nice thing. So even in the student version, it'll let you mesh whatever. As long as you're just can't run a simulation at a high. Actually, my student, he was producing. Just didn't run it yet. It's a nice little, I don't know if it's intended.
Yeah.